Well, happy morning to you all. And I just wanted to take a few minutes just to run through a couple or at least a few things for you this Monday morning as you get ready to take your Chapter 9 and 10 tests. So the test again is 50 points. What you're going to expect to see is basically three FRQ questions similar to the ones that you saw on your review packet. There are 6 of them on the review. Basically, we're picking 3 problems kind of similar in nature, things that we've asked on that review packet and or in these check-in questions. And what I want to make sure that all of you do, and some of you have done just a fantastic job doing it, is making sure you include everything that I'm going to be grading and assessing on some of these questions. So if you're doing like a test of significance, so that's kind of why I picked 10-2 is so I can talk about the test of significance and the confidence interval problems, what I'll look for. So on this one, obviously many of you have done it, but I'm not going to go through it step by step, but I'm just going to talk about what I'm going to look for. A problem like this might be worth, say, 12 to 16 points on the test because there's going to be a lot of things that I'm going to look for. So again, what I'm looking for is that 4-step process: state, plan, do, conclude. So you're going to need to state your null and alternative hypothesis. So you can use the symbol notation. That's just fine. I actually prefer that you do use the symbol notation. But once you use the symbols, you gotta make sure you define what they represent, okay? Put it in the context of the problem. Take the extra 10 to 15 seconds to write it in context of the problem. Okay, so I can just tell you right now, something like just the null hypothesis or just the state part's like going to be worth 3-4 points depending on the problem. The plan is usually worth 4 points. I'm going to look for 4 things. You need to see what type of test, be specific, 1 sample versus 2 sample, z-test versus t-test, or confidence interval. That's very important now because now all of a sudden we have 1 sample test, we have 2 sample tests, we have 1 sample confidence intervals, we have 2 sample confidence intervals. The only thing that won't be on this test is 1 sample confidence intervals because that came from Chapter 8. But I'm going to look for random, normal, and independent. And you got to tell me, be detailed. Don't just say, yep, simple random sample. Okay, or just check, yep, it was random. Tell me how many people they sampled. Okay, and if you can, what type of people or things or objects or whatever they are. Normal, depending on what type of test you're doing. Remember, normal for means, that's the wonderful central limit theorem if we have it. If it's less than 30 and you got the data, yeah, you're going to have to graph it and tell me that there's no strong skewness or outliers. Okay. However, if we're talking about, if we're talking about proportions, remember that's where you're doing n times p and n times 1 minus p is greater than or equal to 10. So make sure you do that. And make sure with the test you're doing the null hypothesis as your p in there for normal. That tends to be a common mistake that I'll see a lot of times when students do the test. All right, independent, make sure if you are sampling without replacement, check to make sure the population is 10 times greater than your sample. So then when we get to the do part, this is where it could be worth, anywhere between like 3-5 points. Okay, I'm going to look for the formula. Are you plugging the values into the formula? Are you simplifying? Are you getting a correct t or z score? This one is a t score. Are you doing the right, calculating out the right p-value? This was multiplied by 2 because in the actual null hypothesis up here, or alternative I should say, it's a not equal to test. So we actually have to look at the lower bound and upper bound values, hence why you double it. Degrees of freedom, remember it's n minus 1. Take the smaller of the 2, okay? So that gives you actually a greater p value, and I'll guarantee that it works in both situations. Once you have your p value, you got to make a decision. And here I'm going to look for 3 things. Can you tell me what the p-value means in the context of the problem? That's kind of this first part. It's basically the percentage of your result or one more extreme happening if the null hypothesis is true. Then showing me that you compared your p-value to a significance level, and whether you reject or fail to reject. That's the second part. The last part, what does it mean in context? Do we have statistical evidence or don't we have statistical evidence? Okay, to suggest the alternative. We never prove the null to be true. We're just trying to show that basically try to show that the alternative is false, at least in a statistical sense, or at least we have statistical evidence to suggest it is. Now, the only difference between a test and a confidence interval is obviously you don't have the null and alternative hypothesis. You still want to state what type of interval, and you still got to define the means, okay? Define your variables. Don't forget to do that. Students tend to forget to do that with confidence intervals when it deals with two samples. Again, make sure what type of test you're doing. Random, normal, independent, basically almost the same. The only big change is like when you're dealing with proportions is in a confidence interval you're using n times p hat, while for a test you're using n times p sub 0, the null hypothesis. That's the subtle difference, and that definitely can get you in a little bit of trouble, or at least on our test, at least have you lose a point if you make that mistake. Again, show your math, okay? I need to see all your work, the best that you can do, okay? Many of you have been doing a great job doing it on your own paper and like submitting the pictures. Just make sure I can easily see those pictures, okay? So now, once you get your confidence interval, make sure you can interpret it in the context of the problem. Know how you can take a confidence interval. Like for instance, when I look at this particular confidence interval, okay, it goes from negative to positive. So like if I was using it to suggest whether or not I have statistical evidence, since zero's in here, it suggests basically that I don't have statistical evidence that there's a difference, since I could have had negative values or positive values. Anytime zero is captured by a confidence interval, you don't have statistical evidence. Okay. All right, one of the last things that I do want to talk about actually goes to the front page, and that came up early in chapter 9, and that's talking about type 1 and type 2 errors. So make sure that you know what a type 1 error is and what a type 2 error is, and know how to describe those. So when I think of a type 1 error, I'm thinking about, oh boy, I rejected the null hypothesis. I made the decision I kind of wanted to make, and I made a mistake. Okay? That's the type 1 error. Okay? So then describe what it means in the context. You have to think about how it is phrased in the problem on describing how that happens. I always think of with type 1 errors is, on an assembly line, I destroy a good batch of product, and then the consequence of it is, okay, I said the product was bad when in fact it was good. And so I actually destroyed a bad batch of product, so I cost the company a little bit of money. The type 2 error is the reverse. It's actually saying, okay, the product is actually good when in fact it was bad. So what the consequence there is, I actually sent that product out. And because I sent that product out, all of a sudden customers are getting some bad product. So a consequence could be, they're not happy. They called. Potentially company might have to do a recall. But again, the type 2 error is basically saying the null hypothesis is A-okay when in fact it wasn't okay. So that's the type 2 error. So make sure you're able to describe those in a context of a problem and come up with a consequence with each. Okay. All right. That's about all I have. If you do have questions, feel free to email me on Monday and Tuesday. Just make sure you get that test done by Tuesday. The rest of the week will be dedicated to studying and getting ready for the AP exam. So lastly but surely, as I always say, good luck, bon chance. May whatever force or forces be with you on the Chapter 9-10 test. Talk to you soon.